arrhenius acids and bases. So if you remember, I said arrhenius acid, so we have three definitions. One of them is arrhenius, which talks about what is an acid. Like how can you define an acid or a base? So arrhenius acid says it's a chemical compound. Arrhenius acid, it's a compound. This part is important. It's a compound that increases the concentration of hydrogen ion. So it increases hydrogen ion and in aqueous solution. So it must be in water. Since it's in water, it's aqueous solution reacting with water. So H can never be alone in water. It has to react with the water to become H3O. That's why whenever we see arrhenius acid, we are, instead of just looking at H or looking for H, we are going to look for H3O. Same thing for arrhenius base. Arrhenius base is a substance that increases the concentration of hydroxide ions, OH, in aqueous solution, okay, in water. First, let's start with the acid, aqueous solution of acids. Arrhenius acids are molecular compounds. All the acids are molecular compounds. Okay, are molecular compounds. And by the way, arrhenius acid and bases, it's a traditional definition. So it's for the traditional acids and bases. They are for the acids and bases that we have learned their names. Because you will see afterwards when we talk about the other acids and bases, they are not traditional, they go over more advanced or more detailed stuff. But for arrhenius, it's just for the traditional acid and bases. So arrhenius acids, all the acids are molecular compounds. If they are molecular compounds and they form ions, so they are ionizable, which they ionize one of their hydrogens. So they lose one of their hydrogens. They separate one of their hydrogens or their hydrogen. Arrhenius acid hydrogen ile cevapta. Hydrogen ile cevapta. And of course, the water sources are called aqueous acids. If you remember in the previous lesson, we said, for example, these were gases. These names are gases. But when we put them in water, they become acid. Same thing here. So the water solutions are known as aqueous acids. And of course, since they form ions, so all electrolytes. All aqueous acids are electrolytes. How can they become electrolyte? Why they are electrolyte? Why they are ionizable? Why do they ionize? Because acid molecules are sufficiently polar. If you remember from chapter 2, we said if something has a high polarity, it will ionize. It will ionize and become ion. It will be separated. The bonds can be broken. So if they are polar and the bonds are weak, the bonds can be broken. Water molecules attract one or more of their hydrogen ions. So the water will attract the hydrogens and they become ions. And what is left? The negatively charged ions are left. Negatively charged ion can negative can be. For example, every acid is like this, everyone. Every arrhenius acid is like this. We have this is the acid, reacts with H2O, becomes H3O and negative. HCl reacts with H2O, becomes H3O and negative. We have, let's say, HClO4 reacts with H2O, becomes H3O and ClO4 negative. We have, let's say, what else do we have? HBrO3 reacts with H2O, again, becomes H3O and BrO3. هر همین همو اسیدگان همو arrhenius اسیدگان لگل H2O reaction اگه H3O آنها نکمان بود درست کرد. H3O negative یک من بود درست کرد. H3O negative یک من بود درست کرد. باشه. Just like these equations. So all of them are like this. They ionize. هميان چی again? هميان ionization again. هميان ionization again. Now we have to separate the acids into two parts. So we know we learned about the acids. They ionize in water to become ions. They become aqueous when they form their electrolytes. Since they are all polar and kind of high sufficiently polar. So if sufficiently polar, it means that they will become ions. Because the water molecule can attract hydrogen from the acids. أو أتوان چين لبكات إيش كان لبكاته أسيد كان. باشه كورنا.
مامسا.
بله.
برسيارك. سبو أرهنيس أسيد وبيسكة يعني نمونيك معناته على concentration هيدروجين زورة أو كاتبه يعني يبي دياري كين كأسيد يعني بيسوا.
بله. تو زين شو أنا ورده اسمه أسيد كان لبركين. إما أسيد كان لبركين إنجا. كأسيد كان من لبركت تو أناسي توا أسيد بس شي درسكات أبي أشتريه درسكات ودواترج مثلا كلا دواتر definition كان يتر ماخون ورده هر يكي كان وصفه كان أنا نسين أسبون منا أنا نعمل إشنافي بس إشنافي بس إشنافي compound double compound شي درسكوا أشتريه درسكوا so HNO3 is arrhenius acid
H3 درسكة أو arrhenius
طبعا بزور طبعا باشه مادام H3 درست کردووە کاتە arrhenius acid باشه دیان Now what about the strength? Are all the acids equally strong? No, we have strong acids and we have weak acids. So strong acid means is the one that ionizes completely. كاتت شيء كان strong acid كان أنا بطاوتي ionize كان بطاوتي ionize كان and we can also say release high amount of H3OH يعني بس تنها H يعني تعمل H3O كشماني كواتا strong acid كان كمانا even if they are dilute so we don't need to make them concentrated in order to make a lot of H3O just by dissolving any amount of a strong acid all of the acid will become ionized all of the acid will become ion همو acid بيبقى ion همو acid بيبقى ion هيجي نامنه تو هم يبقى أنا تو عندي رأي ابن سين no هرچند به نود نسیم أنا بالام يري رونتري نسیم no molecules are left of acids all have become ions هیچ لینکن نما هیچ مولکولکن نما کاتا no molecules او no molecules توزن اشید مثل آدره are left of acids all have become ions همه ببا ion كواتا مادام strong acid كان همه ببا ion كواتا عينا بياناسي چی وامه لکاتی چپتری دوش اخوان من بياناسي strong electrolyte كواتا همو strong acid كان شين strong electrolyte so all of the strong acids see it's just like chapter 2 it's just like the same definition they are strong electrolytes as well the same note after ionization aqueous strong acid solution contains what contains hydronium ion and anions that's it but not acid molecule see the same as this rule or this note no molecules are left of acids all have become ions hamibuba ion such as HCl4 HCl HNO3 which I'm going to teach you how to recognize strong acids and weak acids. But for now, we are just talking about their principle, their explanation only. So strength of acid depends on what? Strength of acid depends on polarity of the acid, which is directly. So the higher the polarity of an acid, the stronger the acid. But it's inversely proportional with bond strength. Why? Because if the bond is strong, it means that the bond cannot be broken. It means that it cannot ionize easily. It cannot ionize easily. باشا كواتا اگر بوندك بقوت به بطاطي بأساني نتواني ionization كات بأساني نتواني ionization كات كواتا چی رویت او کاتا ناشکت بوندکی ناشکت بەڵام ئێستا لێرەیە ئەگەر بۆندەکەی ویک بێت bond strength کەم بێت if the bond strength is low if the bond strength is weak and slow, then it can the hydrogen can be broken easily, so it will ionize more. Like I have written it here. Polarity is directly proportional with ionization, is directly proportional with strength of acids. This is strength of acid. But strength of acid is inversely proportional with strength of bond or bond strength. بەڵام strength ئەسیدەکە عکسی bond strength ئەگەر چکە بۆ ئەگەر بۆندەکەی بەقوت بێ the stronger the bond the more difficult to break the bond, so it will not ionize, so it will not become a strong acid. Ionize زۆر ناکات کەواتە polarity و ionization ئەسیدەکان strength ئەسیدەکان directly بەڵام هەرسیکیان inversely لەگەڵ bond strength. باشە کوڕینە. So when we say ionize completely, yani ionize easily, yani bond can be broken easily. کەواتە بۆندەکەش بە ئاسانی دەتوانێت بشکێت.
مامۆستا
بەڵێ
ئەزانێ بتوانی یەک جایتر سترێنگی ئۆفۆسیدەکان دووبارەکەت و یەک جایتر خاڵەکان
بەسەرچە کوڕمە کە لە کاتێک ئەڵێ strong acid یعنی بە تاواتی ionization ناکات
باشە
یعنی هەمووی بە ion یعنی مۆلیکولمان نامێنێ ئەمانە پێیانەوە strong acid کە هەمووشی بوو بە ion کەواتە بێ بە strong electron بۆیە لێرە بەس چیمان بۆ دروستە بێ بەس ion-مان بۆ دروستە بێت ion-ەکان چین عادەتەن لە ئاسیدەکانە هایدرۆنیۆمە H3O لەگەڵ ئانایۆنێکە ئێوە تا مەسەڵەن لەسەرەوە H3O لەگەڵ ئانایۆنێکە بۆ نمونەوەکو HCl4 و HCl و HNO3 طبعا ئاسیدەکان
بەس ئایۆنایزەکان سترۆنگی ئەسیدن
ئەبێ بە تەواوەتی ئایۆنایز کات جا دوایی کە ئەمەمان خوێن بڕۆ چاپتەری 2 تێبڵێک کە دروستم کردبوو تێبڵێکی لە چاپتەری دواتیا بوو هینە گرافێکم کردبوو کە چۆنە لەگەڵ ئەوە بەراوردی کە زۆر جوان تێگەیت زۆر جوان بەراوردیەکەیت ڕێگە بێ بەمان پێ لەمەشتا کەواتە لێرە نەخێر ئەبێ بە تەواوەتی ئایۆنایز بکات مەستا لەوەی دواتری خۆ لە سترۆنگ ئەلێکترۆلایت شەوا بوو ئەبێ هەمووی بێ بە ئایۆن هەشمانە ئایۆنایزەکە بەڵام کەمێکە بەشێکی کەمێکە بەس لێرە هەمووی بێ بە ئایۆن هەمووی ئەو پێوتر سترۆنگ ئەلێکترۆلایت ئاجا عادەتەن ئەوانە کامانن ئەوانن کە پۆلاریتیان بەرزە عادەتەن ئەوانن کە بەڵێ
ئەبم بە ئایۆن ئێمەیان ئەبم بە ئایۆنایز دەبن
یعنی هەر عین قسەیە کەوتمان ئایۆنایزەکات یعنی هەمووی بە ئایۆن باشە ئەوە عین قسە ئاگرێتەوە یعنی پۆلاریتیشیان بەرزە بۆند سترێنتیشیان کەمە یعنی بۆندەکانیان بۆندی چی بۆندێک کۆڤەلەنت بۆندەکانیان یعنی بۆندەکان بە ئاسانی ئێچەکە بە ئاسانی لە هینەکە ئابێتەوە بە ئاسانی لە ئانایانەکە ئابێتەوە باشە
باشە باشە
چێتە پرسیاریە کوڕێمە باش ئێستا یەک نۆتمان ماوە. This note, strength of acid is unrelated to the number of hydrogen in the compound. Strength ئەسیدەکە هیچ حەقی نییە بەسەر ژمارەی هایدروژینەکەەوە لەناو کۆمپاوندەکەیە. چکە وتمان مەسەن releases hydrogen a lot وانە بۆ نمونە H3PO4 weak acid سێ هایدروژینیشی تیە باشە کەواتە حەقی نییە. حەقی بەسەر چیەوە هەیە؟ حەقی بەسەر ئەوە هەیە تا چەندێک هایدروژینەکە ئایۆنایزەکات کە چۆن ئەزانن دوای ئەی خوێنین پێتان ئەڵەم ئەگەر ئاوا بوو ئەمە سترۆنگ ئەگەر ئاوا بوو ویکە. Okay, so it's not related. It doesn't mean that if you have 3 hydrogen then it releases a lot of hydrogen. It may not. Why? Because it cannot ionize. It cannot be, if the bond is not broken, then we cannot benefit from the hydrogen. Okay, so that's why it cannot become a strong acid. Be a weak acid. What is a weak acid? If it releases few hydrogen ions in the electrolyte solution, then it's a weak acid. In other words, we can say ionize harakat, but partially. Instead of completely, it will ionize partially. Ionize partially. بس تنها بشكل ببعين. What does ionize partially mean? It means some of the molecule only becomes ion. Most of the molecule remain as molecules, just like chapter 2, the weak electrolyte. So after ionization, when it says ionize partially, after ionization of aqueous weak acid solution contains what? 1 hydronium ion, okay, anion, okay, and C dissolved acid molecules. So we don't have a problem with the solution. It will dissolve. It will dissolve, but it cannot become ions. It will dissolve in the water, but it only cannot become ion. For example, HCN is a weak acid. It's a very weak acid. HCN is a very weak acid. HCN weak acid is زور weak. HCN out of 100,000 molecule when dissolved in water, all of the 100,000 molecule will dissolve in water, but only 2 molecules become ion. Yeah, it means that 2 molecules have become ions. It means 999,998 molecules stay as molecule. So most of the acid stay as dissolved molecules. The same thing that we said in chapter 2. If you remember, we had a question even for HF. We said most of the HF molecules stay as molecules, non-ionized molecules. Only a small portion of it, only a small part of it become ion. The hydrogen is lost. All the rest are dissolved, but in a molecule, in a non-ionized molecule form. Kawata لێرەیە زۆربەی زۆری وەکو مۆلیکوڵە منەتۆ تەنها بەشێکی کەمی ionized. Same thing for acetic acid, which is like only 1.3% of acetic acid will ionize. 98.1.7, yes, 98.3% will remain as molecules. کەواتە زۆربەی ئەسیدەکە وەکو مۆلیکوڵە منەتەوە. تەنها بەشێکی کەمە بە ion. Only a small part of it will become ion. All organic acids are weak acids. All organic acids, anything that contains carbon, oxygen, hydrogen, like this, such as acetic acid, are weak acids. Organic, whenever you see organic means carbon and hydrogen. But organic acids contain also oxygen. Böyle chapter yanza ekhoniz. بس ما تعود يسخن متى أسيدك أسيدة ماشي كورينا. Then how can we distinguish between weak acid and strong acid? And by the way, look at the arrow. Strong acid is one direction. It's irreversible. But weak acids, just like weak electrolytes, they are reversible. They are reversible. Why? Because not all of the molecules can become ions. They are always in an equilibrium position where if a molecule wants to become ion, 2 ion more must come back to that molecule. كاتبت شيء بيجر molecule like بيو جاب بدو ion أبى دو ion يتري يجب بجرته بيته molecule. So there is always back and forth. That's why they are reversible. And they are weak acids. Weak electrolytes, sorry. So weak acids are also weak electrolytes. All right. Then how can we distinguish between strong acids and weak acid? How do we know if an acid is strong or weak? We cannot memorize every acid and base. But what can we do? For binary, yes. For binary, we only have 5 acids. We can memorize them. For binary acids, HBr, HCl, Hi, just like in chapter 2, they are strong acids. HF and H2S are weak acids. هاتا لباينري كان أبي لبريكين memorize. HBr, HCl, and Hi are strong. HF and H2S are weak acids. But we have a lot of oxyacids. We cannot memorize all of them for oxyacid. Then how can we find strength of oxyacids? By the difference between oxygen and hydrogen number. How? If the difference between an oxygen and a hydrogen inside an oxyacid is 0 and 1, it's a weak acid, such as HNO2. Look at HNO2. We have 2 oxygen. We have 1 hydrogen. So 1 hydrogen. 2 and 1, what is the difference between them? 1. So if the difference is 1, then it's a weak acid. HCl, 1 oxygen, 1 hydrogen. So the difference is 0. 1 minus 1, 0. So the difference is 0, then it's a weak acid. H3PO4, 4 oxygen and 3 hydrogen. 4 minus 3, what's the difference? 1. So it's a weak acid. But this is only for compounds. Only for compounds, not for ions. كل دواتر أبو ion كان يجيشوني. بس بو compound ده بس. But if the difference is 2 or 3, then it's a strong acid. For example, HNO3. 3, H is 1. What is the difference? 2. So it's a strong acid. HClO4. HClO4. We have 4 oxygen and 1 hydrogen. What is the difference between them? 3. So it's a strong acid. جوازي كان شنكا. سيرجع 4 oxygen ماني لقال لك هيدروجين. سي رقميا جوازة كواتا كودو أترجي إخواني بوشي واه strong. كواتا strong acid. بوايا ما يزاني. بيزنا قبشين هموس أكسياسيدا كان لبركن. بس تنها أو رولبزانا تا. أول كان بيستا كان لبريكين باينري أسيدا كان كبيانش أسيد ما هبو دوانيان ويكا. Okay. So these are the weak and strong acids. That's why if you know these notes, you don't have to memorize this table. Only as an example, like if you want to see how do they react with water, HCl, for example, H2SO4, HClO3, HClO4, they react with water with single arrow, become H3O negative. That's it. هيبقى negative. Kurna ka speciali هي تاستا. كواتا strong acid كان ionized completely, weak acid كان ionized partially. كstrong ionized completely يعني همو molecule كان بو ion هیچی نماوتو acid كمان نماوتو بلام weak acid كان نخير acid كاش ماوتو تواوتو بلام بشي كشي بو ion بلام زوربي بو molecule ماوتو باشا كورينا چه بسیاری هست Now, let's get to know bases. Let's define bases. So we said for acids, all of the acids are molecular compounds. All of the acids are molecular compounds. If you go back to like the first page of your booklet, as you can see, all acids I have written it under polar and molecular compounds. What about bases? Bases can be ionic compounds, can also become molecular compounds. We have both of them. First, most bases are ionic compounds. So, how do we know if an ionic compound is a base? If the base is composed of metal cation, like Na, and a hydroxide anion, OH. So every metal, if you see a metal with OH, then it's a base. Her metal كبيني لقوا OH أو base. It's an ionic base, let's say. It's a base that is composed of ionic compound. That is an ionic bond. And if they are ionic compounds, then the strong base will do what? Instead of ionization, they will dissociate because they're ionic. كهذا تشيشن لبري ionic compound dissociate can نكو ionization. They don't ionize, they only dissociate. They only dissociate. Okay? So just like ionic compounds, when they dissociate, NaOH becomes Na and OH. Or, for example, CaOH by 2, when dissolved in water, just like we studied in chapter 2, dissociation is just separation of the ions, become calcium and hydroxide. That's dissociation. It's just separated. It's just separated. The ions have been separated from each other. They have become calcium and hydroxide. But some other more bases are polar molecular compounds, such as ammonia, which if they are molecular and they become ion, instead of saying dissociate, we have to say ionize. So ammonia produces hydroxide ions and when it reacts with water molecules. This time when the ionization occurs, this is kind of new to you. I'm a taze. According to Arrhenius basis, if a compound increases OH in a solution, It's a base. For calcium hydroxide NaOH, yes, they have increased the OH. Same thing for NH3. But this time we have to recognize NH3. NH3 is one of those compounds, very important. It will be repeated over and over again, NH3. So it is a base. It's a molecular base. But this time, instead of the hydrogen, the H2 to take a hydrogen from NH3, the NH3 will take a hydrogen from the H2O. اما لو هنا بشتري مثلا تشيبو اسيدا كان H2O H2 لا اسيدا كان مثلا امجالان بعكسه NH3 H ل H2O كاسنه NH3 تو انا هي H ل H2O كبسنه. So when H2O loses an H becomes
خاصة كذابيت تينا كني
باش بوري وهذا كورينا NH3 لقل H2O رياكشن كان لبري اوي H2O ك H ل NH3 كبسنه NH3 ك H ل H2O كاسنه عكس بتو بعكسه باشا كواتل ليرة او اتش كدروس سبه ليرة لبري او اتش 3 او دروس ببي او اتش دروس سبه كو اتش دروس بو كواتا من ليرة ان اتش 3 چیه ان اتش 3 او اتش دروس نکردو کواتا ارینس بیزه کواتا ان اتش 3 ارینس بیزه باشا كورينا انجان لم نمونيش بس ان اتش 3 مان هي كتو بيستكا بيزاني نموليكولارا نمونيت المان هي بلان اور رياكشن قد نانوسين هیچ پیس من پی نابد بلان موی كتو بيست بيزاني the thing that you have to know is NaOH. NaOH is an ionic base. It's just separation. لأخواري شو بيز مان هي لو تيبله Now let's talk about the strength of the bases. Strength of the bases. The strength of a base depends on the extent to which the base dissociates. Strength base ka aynen شون اسيدا ka depende كده سري تاچن ka ionization ka مش عين شد تاچن dissociate ka خود ionize ka. A. All soluble ionic bases are considered as strong bases. All soluble ionic bases are considered as strong bases, which they dissociate completely into ions such as NaOH, COH by 2. Look at the table. So strong bases are also strong electrolytes. So all of these are strong bases. E8, CSR, BA. These three are group 2 metal. If you want to memorize, they are from group 2. The others are from group 1, metal كان group يكن. And please add this one. أمشي بوزياد كان. Lithium hydroxide. All of these here are group 1 metals with OH, which they become strong bases. همان چین؟ همان soluble. The group metal of group 1, lithium, cesium, rubidium, potassium, and sodium. Metal كان group يكن. لقى OH هاتن أي ابن بس strong. Okay. كواتا أو مجموعات وبالبيزاني هميان كسترونغن أو مجموعة كلا تيبلك أنا مش strong basin أبي بباشي بيان ناسيتو. You have to know all of the strong bases here, including the lithium hydroxide. So all of the names are a metal with hydroxide, lithium hydroxide, cesium hydroxide, rubidium hydroxide, potassium hydroxide, barium hydroxide, strontium hydroxide, and so on. So we talked about strong bases. We said everything that is on the left side of this table, like elements of group 1 especially, with OH become a strong base, like potassium hydroxide, like this. And they're all strong electrolytes. Same thing for B. Like we can say ammonia and all organic compounds containing nitrogen. Ammonia plus all organic compounds containing nitrogen in the structure are weak bases. And since they are molecular compounds, we said bases are two parts, ionic compounds and molecular compounds. Since these are molecular compounds, they ionize, but ionize how? Partially. Ionize partially to form OH, like NH3. Everyone, the most important one is actually the NH3. But we have two other compounds. This one, the name is Aniline. Okay, you don't need to memorize the structure very carefully, very like in detail, because until now, no questions has been asked about aniline. But the name of the codyne here, which is also a weak base, the name is important, is a pain reliever and a common cough suppressant. So it's pain reliever for pain and for cough. Ambo coca, ambo azashken. But we have a special ionic compound. We have three special ionic compounds: aluminium hydroxide, copper hydroxide, and magnesium hydroxide, which are actually bases and they're ionic compounds, but they are considered as weak bases. Why? Because their solubilities are low. Emma, Alain, ionic compounds are strong, ionic bases are strong bases, except for these three. If I mention it somewhere like this, ionic bases are strong bases except for these three, which are aluminum hydroxide, copper hydroxide, and magnesium hydroxide. Why? Because they have low solubility. So if I draw a graph for you to distinguish all the bases in an easier way, bases, ionic bases, or let's say soluble, it's better to write it like this. Strong bases. The strong bases are soluble ionic bases, which is a metal with OH and dissociate. Okay, but weak bases which are molecular ionize partially, such as NH3, which is the most important one and it's the most common one. Weak bases, also we have low soluble ionic bases, which are only these three: aluminium hydroxide, magnesium hydroxide, and copper hydroxide. Okay. So that's how we distinguish, we classify the bases. Do you have any questions? All right. Now let's start with section review questions. The questions are just like, since this chapter we don't have a lot of calculations and solving, so these questions, most of them are just the properties that we have to review it and say it again, or repeat it again. First, let's look at the first one. What are 5 general properties of aqueous acids? وجود تبينس property كي أسيد مبنوسة. يوهر بينس property كي future. They taste sour, change color of indicators, react with metals, react with bases. They are electrolytes. That's it. And when it says name some common substances that have one or more of these properties, you can say like milk or sour milk and things like that, vinegar, and so on. هموش تكاين مثلا تواني بلين مثلا اواني كلا تيبل كاي خانمانه او نمونه كان كي خانمانه اتواني بس نمونه كان بنسي چكو ايش داوي نمونه كانك يعني وكو شتك لا نمونه كان باسيكا. That's it. Question 2, as you can see, HBRO and HBRO3, actually they were not in the table that was given by the book. They are from the essays that we have written by ourselves. HBRO, HBRO3 أوانا بون كخوما نسيما, which HBRO is hypobromous, HBRO3 was bromic acid. أوانا بون كخوما نسيما. But they are not given in the book. Why? Because the book thinks that you know HClO3 and HClO. That's why the same thing can be done for HBr and HBRO3, just like we did in the previous lesson, the last lesson. Everyone, for the answer key here, please delete this 4. أما هي كتابك شبزنا زنبوها خلط نسيانا. أملي تيم هادرو سادو أنا ويشش بصرنا. And change this 5 to 4, change this 6 to 5. All right, question 3 says, what are the 5 general properties of base, of aqueous base? So again, the 5 properties of base: taste bitter, slippery, change color of indicators, react with acids, and electrolytes. Name some common substances that have one or more of these properties. Just name the name of the bases: ammonia, milk of magnesia, antacids, and things like that. Question 4, why are strong acids also strong electrolytes? Which is strong acid can strong electrolyte? They have the same common thing. Both of them ionize completely. Because strong acid ionize completely, they become all ions. That's why they are strong electrolytes. That's why they can conduct electricity very well. كواتا جوابك چیه؟ Which is strong electrolyte can strong acid can strong electrolyte? لبري ionize completely. هم يبقى ion. But B says, is every strong electrolyte also a strong acid? هرچی strong electrolyte strong acid ایشه? No. Not every strong electrolyte is a strong acid. Why? Because there are other stuff that are also strong electrolyte. همون strong electrolyte strong acid نیه. We also have strong bases. We also have salts. All right? We also have other ionic compounds, other substances, which they can become strong electrolyte. شتیش منظوره که به strong electrolyte. هر acid نیه. So the same thing, that was the answer. No materials other than acid can ionize in aqueous solution, can become also strong acids. فاتش شتیش منه به strong acid. هر acid نیه. به strong electrolyte ببره. شتیش منه به strong electrolyte. هر acid نیه. Question 5. A classmate states all compounds containing hydrogen atoms are acids, and all compounds containing OH groups are bases. Is this correct? Do you agree with this? I am شتقصيك الراستا هرشي H تيابو أسيد به هرشي OH تيابو بيز به. So كيف هي نمنا من
I
باته؟
don't take D.
Yeah.
I don't take D.
No,
Because
you don't. Why?
H2O,
Give me an
H2O,
example.
for example, is not acid.
Exactly. H2O is not acid. Or a better example. For example, NH3 has hydrogen, yet it is a base. أو تا NH3 حبز يشتيا خو HKش ديارني. We don't even see the OH. And yet it's a base. Same thing. And all compounds containing OH groups are bases. OH group, it doesn't say hydroxide. It doesn't say with metal. There are other things that we have OH group. The most clear or the most obvious one is CH3COOH. It contains OH. It has OH group and it is an acid. أوتا NH3H هي بيزيشة بلام CH3COH OH هي أسيديشة فهذا شرنيه هرشي تو OH بيني بلاي ولا بيزة. Okay.
يعني ما مصا OH هم بيسة وهم أسيديشة.
نانا كرم أوي سيرك بو بيزة كان جواز بو بس أبو ببيس أبي OH هيدروكسيد به يعني نيجاتيف به لقلب ميتالك أبي أنجا ببيس.
يعني كنيجاتيف نبو أسيد.
نيجاتيف نبو لقى ميتال نبو نابي ببيس.
ماشي.
ميتالش.
طالما ما كان نيجاتيف بو لقى ميتال شابو أو كاتش.
أو لا بيزة وطاع يكسر بيزة. مثلا ميتالك او اتشك يعني هاد كاتتو ميتال او اتش بيني يعني او اتش هيدروكسيد تشارجك نيجاتيفا او بيزا.
اگر يعني اگر تشارجك بوزيتيف ولقى ميتالك
تشارجينيا انسيك لا شتيو ماني تشارج بوزيتيف من هرني او اتش ماني تشارج بوزيتيف
همي نيجاتيف يعني
همي نيجاتيف بلام هنجر او اتش مان هسيرك وقر ايوني كومباوند به نيجاتيف به اگر ايوني كومباوند نبو هر نيجاتيفني هر اصلا تشارجرني باشر موليكول يكون باكوفالنت بوند بيكون مساوي طا او اسيديك اسيد.
تيجش
ماشي. Okay. Let's start with section 2. Section 2, the second definition. Now we start with acid-base theory again. So the first definition was Arrhenius. The second definition is Bronsted Lowry. It's named after two scientists. One of them is Bronsted, one of them is Lowry. Lowry, I think, is English. Bronsted is Danish, Danimarkia. Lowry was English. So Bronsted Lowry acid and Bronsted Lowry base. We have both of the definitions. They have another definition for acid and bases. Bronsted Lowry acid, it says it's a molecule O ion. كواتا اللي رأت وانا تشيشبه molecule bit yan ionish bit. أتواني molecule bit أتواني ion bit. But it doesn't say about hydrogen or things like that. It has to produce hydrogen or anything like that. It must be a proton donor. It must be a proton donor. It has to donate a proton. What is a proton? It's a proton. H is a proton, as we studied in chapter 2. A Bronsted Lowry base is a molecule or ion, again, that is a proton acceptor. So it has to accept a proton. It has to accept a proton. Look at this example. Hydrogen chloride acts as a Bronsted Lowry acid when reacts with ammonia. Look at here. We look at HCl. It has donated a proton. How do we know? Look at it. It has become NH4 and Cl. Who has donated a proton? HCl. Why? Because look at it. The HCl has been left alone. It has been transferred to what? To NH3. So HCl is proton. P positive means proton. It's a proton donor. NH3 has accepted the proton. So it's a proton acceptor. Now, let's go back to the definition. A Bronsted Lowry acid is a molecule that has a proton donor. So HCl becomes what? HCl is a Bronsted Lowry acid. So it's BL. BL means Bronsted Lowry acid. Then NH3 has accepted a proton. According to the definition, if it has accepted a proton, it becomes Bronsted Lowry base. كورينا الأرينيوسا بس تنهوص في يك compound معنا كرت. In Arrhenius, we have only defined one compound, but in Bronsted Lowry, we will define both of them. Both sides. The one that has donated, the one has also accepted. Same thing. Look at HCl. Look at HCl. HCl has donated a proton to H2O. HCl has donated proton to H2O. H2O. So HCl is a proton donor. H2O is a proton acceptor. Then HCl is Bronsted Lowry acid. Then H2O is Bronsted Lowry base. Okay? So in this example, HCl acts as both Bronsted Lowry acid and arrhenius acid. كاتل HCl بوبا تشوشيش بوبا Bronsted Lowry acido بوبا arrhenius acidish بو وصفي arrhenius acid شيبو. If we go back to arrhenius acid, why is it also arrhenius acid? Arrhenius acid, a compound that is produced, that can produce H3O, that can release H into water. Yes, it's in water. Has it produced H3O? Yes. So it's arrhenius acid. So if I write just below them again, like this, HCl with H2O, it becomes H3O and Cl. جاري كتير. أتوان خوش تنجاري كتير أبي نسنو. يعني أتوان هالجر أو reaction you can fit the explanation just below the reaction, or you can write it again in the space next to it. So HCl. Let's start with first one. What was the first one? Arrhenius. 1. HCl, has it produced H3O? Yes. Is it dissolved in water? Yes. So HCl is arrhenius. A means just A means arrhenius. It's arrhenius acid. But look at the rest of the note. But arrhenius acid, arrhenius theory cannot define H2O. So H2O is never arrhenius. But Bronsted Lowry can define H2O. Because Bronsted Lowry is a little bit more broad. It's more wider. Or it's wider than arrhenius. Bronsted Lowry chia pose frawantra. Lachau arrhenius. So arrhenius cannot define H2O. Nothing for arrhenius. But if we look at Bronsted Lowry, HCl has donated a hydrogen to the H2O. So HCl is a proton donor. HCl is a proton donor. That's why HCl can become Bronsted Lowry acid. As simple as that. It's very simple. Has it donated a proton? Yes. How do we know? Look at the product. HCl like H2O. Who has accepted the proton? H2O. So H2O is a proton acceptor. So it can become Bronsted Lowry base. سری وصفانەی ئەم چاو زۆر جیاواز لەگەڵ ئەرینیۆسە. برۆنشتد لاوری وەصفی هەموویان نەکات. هەرچیەک ئێچی وەرگرتبێ و هەرچیەک بۆ ئێچی دۆنێت کردبێ برۆنشتد لاوری وەصفێکات. ئەڵێ ئەوەی دۆنێتی کردبێت ئەوە برۆنشتد لاوریە ئەسیدیشە. هەرچیەکی ژوێری گرتبێ و توێتی ئەوە بەیزە. So look at the next example. Same thing. In this time, NH3, if you remember from the previous lesson, NH3 cannot donate a proton. It will take a proton from the H2O. So proton H2O has become a proton donor. NH3 is the proton acceptor. So H2O is Bronsted Lowry, as I have written it here. H2O is Bronsted Lowry base, because sorry, Bronsted Lowry acid. My bad. It's Bronsted Lowry acid here. H2O گۆڕا کوڕینە. بەپێی ریاکشنەکە ئەبێت سێ ریاکشنەکە بزانین چێ هایدرۆژینی یاو بە چێ. ئێستا لێرە سێرەکەین H2O هایدرۆژینێکی یاو بە NH3. So NH3 وەرگرە. NH3 is the acceptor. So since NH3 is the acceptor, NH3 is the Bronsted Lowry base. Oh, Bronsted Lowry base. Okay. ئەتوانین بە عکسیشەوە بنووسین، یعنی کێشەمان نییە، گرنگەوەی ئەو هایدرۆژینە لە H2O بچێ بۆ NH3. And this OH has been produced due to what? Due to the NH3. So NH3 is the arrhenius base. But if you remember, we said arrhenius can never define H2O, so it cannot become arrhenius. H2O is not arrhenius. H2O can never become no arrhenius acid, not arrhenius base. And in these reactions between these acid and bases, so as you can see, one of them is donor, one of them is acceptor. One of them becomes acid, one of them becomes base. So it is also called Bronsted Lowry acid-base reaction. What is this reaction? Protons are transferred from one reactant to another. From the acid to the base, we call it Bronsted Lowry acid-base reaction. چه پرسیارەتە ئێستا؟ چونکە ئاخر نۆتمان ماوە ئەم نۆتەش گرنگە لەم لاپەڕەیە.
مامۆستا
جان
خۆش بێت، توانی کە تەواو بووی لە شەرحی ئینگلیزی کەنۆتەکەشمان تاواکەک جایتی بە کوردی بیتەوە بخوات
بەسەرچاو کێشەمان نابێ ئەوە شێوە توانین بکەین. حتا بۆی با سەرجۆ بەسەرتانە ڕۆبووی بە جوانی تێبگەیت هەر ئێستا بۆتەکەم. کوڕینە لێرەیە ئێمە دەفینیشنێکی ترمان هەیە، وەصفێکی تری ئەسید و بەیزمان هەیە کە وەصفی برۆنشتد لاوریە. وەصفی برۆنشتد لاوریە لە چی؟ یعنی ئەمان گوێ نایەت بەوەی کە ئەبە ئیلا H3O بە ئیلا OH ئەڵە چی؟ ئەڵێ هەر کاتێک شتێک هایدرۆژینی دۆنێت کرد، هایدرۆژینی بەخشی، ئەوە پێوتر برۆنشتد لاوری ئەسید. ئیتر چ مۆلیکیول بە یان ئایۆن بێت کە لە دواترە نمونی ئایۆنەکە شەخوێنی، ئەوە ئەڵێ پێوتر چی؟ پێوتر برۆنشتد لاوری ئەسید. ئەڵێشی برۆنشتد لاوری بیس هەر کاتێک ئەوەی کە وەری گرت ئەبێ برۆنشتد لاوری بیس. ئێستا بۆ نمونە لە بین HCl و NH3 ئەهان سێک خۆنە H3O تیایە نە OH تیایە، کەواتە هەن لێرەیە ئەرینیۆس وەصفی ئەم دوانە هەر ناکە. ئەم دوانە لێرە و ئەرینیۆس ناتوانە وەصفیان کە. ئەرینیۆس ئەڵێ بێت چی بێت؟ ئەرینیۆس ئەڵێ بێت لە ئاوا بێت، ئەرینیۆس ئەڵێ بێت H3O ببینیت، ئەرینیۆس ئەڵێ بێت OH زیاد بکە. لێرە هیچ ئەوانی تیان نەکردووە. بەڵام کە سێرەکەن لە HCl-ەکە و H-ێک چووە بۆ NH3-ەکە، HCl-ەکە دۆنەرە کەواتە HCl برۆنشتد لاوری ئەسیدە. NH3-ەکە وەرگرە کەواتە NH3 برۆنشتد لاوری بەیزە. نمونەی دواتر HCl و H2O. سێرەکە HCl H-ێکی یاوە بە H2O کە کەواتە HCl برۆنشتد لاوری ئەسیدە، H2O-کە برۆنشتد لاوری بەیزە. بۆ H2O وەریگرتووە. بەبێ وەصفەکە مادەم وەریگرتووە حەقمان نییە H2O هەر چیەکە. وەریگرتووە کەواتە برۆشت لاوری بیسە کەواتە لێرە HCl-ەکە ئەتوانێت ببێ بە برۆشت لاوری ئەسیدیش و ئەتوانێت بە بە ئەرینۆز ئەسید بۆ یەکەمیان H3O دروست کردووە لەناو ئاوایە کەواتە ئەرینۆز ئەسیدە HCl بەهۆی HCl-ەکە دروست بووە بەڵام ئەرینۆز قەت وەصفی H2O ناکات ئەرینۆز وەصفی H2O ناکات کەواتە H2O-کە بۆ ئەرینۆز بە بەرژایی بەجێڵێ بەس لە وەصفی دووەمیانە کە باسی برۆشت لاوریەکەین HCl مادام دووبارە توانێتی H-ێک دوێنێت کات بیا بە H2O-کە کەواتە برۆشت لاوری ئەسیدیشە کەواتە H2O-کەش کە وەریگرتووە برۆشت لاوری بیزە بە هەمان شێوە بۆ H2O NH3-ەکەش نمونەکەی خواردتریش لە نمونەکەی خواردترە H2O H-ێکیە بە NH3 کەواتە H2O بە برۆشت لاوری ئەسید بەڵام لەبەری ئەرینۆز وەصفی H2O ناکە کەواتە ئەرینۆز ئەسیدمان نییە لێرەیە ئەرینۆز ئەسیدمان نییە ئەی چیمان هەیە NH3مان هەیە NH3مان هەیە NH3-ەکە OH دروست کردووە پرۆتۆنیشی وەرگرتووە کەواتە هەمە بێ بە ئەرینۆز بیس هەمە بێ بە برۆشت لاوری بیزیش باشە کاکە سیاکیۆ
باش مامۆستاژیان یعنی ناتوانین بڵین لەبەرەوەی ئەگزامپڵی دووەم H3O تایە ئەبێ ئەرهینۆسش بێت یعنی مەقسەمەوە یعنی ئەرهینۆس بیس ئەوەیە ئەرینۆس یعنی سپێشەڵایزی ئاو نییە هەشتێک
ئەرینۆس سەیری ئەو چکەوتمان ئەگە بیرە بێت وتم ئەرینۆس وەصفی چیەکە ترادیشنەڵ دیفینیشنە ترادیشنەڵە باسی ئەسیدە عەتیادیەکانەکە باسی بیزە عەتیادیەکان باسی شتێ ناکە کە تایبەت بێت باسی شتێک ناکە کە لە بەهۆی شتێکی ترەوە ببێ بە بیس یێگەی ئەو بۆی لەرە وەصفی H2O ناکات
یعنی لە ئەگزامپڵی دووەم ئاتوانی بڵین ئەوەیە برۆنستەد لەورێ لەگەڵ ئەوەی ترە لەگەڵ ئەرهینۆسەوە
بەس سێریکە ئەگەر سەیەکی برۆشت لاوری دامنە ها وەصفی هەردوو مادەکە ئاکات بەس ئەرینۆس بەس تەنها وەصفی یەک مادە ئەسڵەکە ئاکات تێگەی وەصفی H2O-کە ناکات ئەوە نمونەمان زۆرە
ئیمکانە بڵێ ئەمە هەردووچێتی یان دانیشانەوە
چۆن لە پرسیارەیەتەوە ئەڵێ ئەمە چی چیە تۆ بڵێ ئەرینۆس ئەسیدیشە و برۆشت لاوری ئەسیدیشە نمونە زۆر حەلەکەین لەسەرەوە بچکەمە دیفینیشنی سێم بخوێنین کە دیفینیشنی سێممان خوێنی تر تاو هەر هەمویان تقریبا زەمجگەی 5-6 نمونێت بەسەریەکەوە هەر هەمان پێکەوە حەلەکەین ئەوەی پێی بڵێن با بڵێن لە هەر شوێنە ئۆپشنێکمان هەبێ هەمووی حەلەکەین هیچ نوعانە هەڵینە باشە one final note this is very important برۆشت لاوری reaction what is the reaction there must be a transfer of proton there must be a transfer that's why Bronsted Lowry cannot define NaOH نمونەکە بنووسن دیاران نمونەکەم نەنووسیوە بۆ یەک خۆتان بنووسن like NaOH NaOH it becomes Na and OH is there any transfer of proton between anything هیچ transfer proton man here no like this one CaOH by 2 becomes Ca and 2OH in this case NaOH because only arrhenius bases why because there isn't any reaction لبين هنا شيء هي لبرونشت لاوري شيء هي in Bronsted Lowry there is reaction between the acid and the base there's a transfer of proton so there isn't any reaction أو بجانب نسين no protons are transferred only dissociation بس شيء بس dissociation بس dissociate كده كواتا مادام reaction there isn't any reaction there isn't any transfer of proton that's why these examples strong bases what are the strong bases go back to the table lithium hydroxide, LiOH, calcium hydroxide, all the strong bases. What do you mean by strong bases? Ionic bases. Since there isn't any proton transfer, that's why Bronsted Lowry cannot define them, only arrhenius acid. Only arrhenius base, sorry. كورن اللي هي NaOH calcium hydroxide lithium hydroxide ما دام هیچ گۆڕانکاریە هیچ ڕیاکشنێکی تیانە ما دام هیچ ترانسفێرێکی تیانە هیچ شتێک ڕووی ناوە بەس تەنها جیابوونەوەیە بەس تەنها OH دروست بووە پروتون ترانسفێر نەبووە کەواتە بەس ئەرینۆس بیزن بەس ئەرینۆس بیزن
مامۆستا بەس یعنی ئێمە تایبەتە بە سترۆنگ ئەوەیە ئەسیدەکان
بەڵێ بە سترۆنگ بیزەکان سترۆنگ بیزەکان بەڵێ بەس ئەوەیە باشە کوڕینە ئەمە نمونەیەکی کێشە بۆ برۆنشتن لاوری مثلا ئێمە ئەمەوە ئەرینۆسە بێت لە ئاوا بێوانە برۆنشتن لاوری doesn't care if it's in water or not doesn't care for example if it's not in water like HCl and NH3 they form a salt called N4Cl if it's not in water this is an ionic compound this is a salt and this salt is solid and if they are not in water these are gases actually so هاتنا جازيشن لا أبيشانين كواتا بروتونيك ترانسفير بو ل HCl كوا بو NH3 كا سيرو الرسمة كان هادو شي غازة both of them are gases this is HCl this is ammonia when they escape as gases they react in the air combined with ammonia look at the definition look at this explanation combined with ammonia gas that has escaped from aqueous ammonia solution the result cloud a solid ammonium chloride this is ammonium chloride that is dispersed in air كواتا بو باشي كورينا اگر dispersed بالهواء بو باشي chapter 1 chapter 1 what is dispersed in air
Spread in air.
What is that? Is it solution? Chia. What is it? So it's actually a colloid. A solid particle, solid dispersed in air, solid dispersed in gas. It's a colloid. Solid dispersed in gas, it's a colloid. So there isn't any water. It's not, it cannot be dissolved in anything. It will not dissolve in air. It will dissolve in water. Since we don't have a water, it's a colloid. That's why it cannot become arrhenius. Arrhenius. But it can become Bronsted Lowry because a hydrogen has been donated from the HCl to NH3. And a salt is produced, NH4Cl. Okay, this is the reaction that it talks about.